Hello and welcome to Unacademy. Welcome to another episode in our NCERT Fundamental series, where today we bring for you another very basic concept associated with the NCERT and associated with the portion of climatology, and that is insolation and heat budget. Now, while we have discussed from the same chapter the concept of temperature inversion, many of you had requested that we should do a basic concept associated with insolation. So today in this session, we shall be doing that basic concept associated with insolation, the factors which influence solar insolation in many areas, and also what do we understand when we talk about the concept of heat budget. So without further ado, let us take a look into the topic directly. So this topic is again from the Fundamentals of Physical Geography, class 11th NCERT, from chapter 9, where you have solar radiation, heat balance and temperature. Now here, when you hear about the term insolation, what do we mean by the term insolation? So the solar rays, when they reach the Earth's surface, they carry a lot of energy with them. That energy is transmitted in the form of heat and light. Now, when that energy hits the Earth's surface, it has the influence to provide that energy, and it can raise the temperature sometimes, but is not always proportional to the rise in temperature. So here, when we talk about solar insolation, it is basically the short solar wavelength which hits the Earth's surface. So the energy received by the Earth is known as the incoming solar radiation, which is short in terms as insolation. So that is what we refer to as solar insolation. Now, many of us, we have the feeling that any region which receives greater solar rays will always exhibit a higher temperature. But that is not always the case. You have to understand this particular fact very carefully, so please pay attention here. Greater amount of solar rays have got a potential, have got a tendency to increase the temperature of that region. But any particular area, it can also be the case that despite having high amount of solar insolation, might still experience lower temperature. Why is that? That is because temperature overall is influenced by many factors: angle of inclination, latitudinal position, the altitude of a particular area, then for example the wind movement in a particular region, the ocean currents present in an area, the cloud cover present in an area. So all of them basically end up leading to a particular temperature that we observe. Insolation is just one of those factors. So while insolation can lead to a higher temperature, but it is not always the case that insolation will necessarily lead to a heated condition. Now, different parts of planet Earth, do they receive the same amount of solar insolation? The answer is no. The amount of solar rays, the amount of solar energy received in different parts, that is not always going to be the same. It varies from one region to another. So there are a lot of factors involved which determine the variation in solar insolation from one area to another. So when we take a look at the factors influencing insolation, we have the angle of inclination of Earth, the factor of altitude, revolution of Earth, and configuration or directionality of the land. That is, in which direction the land is actually facing. These are amongst the major factors. There are other factors as well. But let us take a look at these major factors which lead to a variation in insolation from one region to another. So when we talk about angle of inclination of Earth, we do know that the planet is tilted on its axis. Now the planet being tilted on its axis means, and also the planet being spherical in nature, means that angle of incidence of the solar rays, that will be different. The amount of distance that the solar rays will cover in the atmosphere, that will also be different. Now here, let's suppose we consider any particular place, and let's take the torch example. Now if you keep or hold a torch in this position, it will emit light somewhat like this. And let's suppose you keep a torch in this position, in a tilted position. Now it will also emit light, but that light will be emitted in a kind of a inclined manner. Now if we consider these torch positions as 1 and 2, and we name this place as A, now place A will receive energy in both the positions of the torch. Even if the torch is kept at position 1, A will receive energy. Even if the torch is kept in position 2, A will receive energy. But in which position will A receive greater amount of energy? Always when the torch is almost vertical. In this case, the energy has to travel through a larger distance. And as energy travels through a larger distance in space, let's suppose, in vacuum, then it doesn't make much of a difference. The energy won't get dissipated. But when the solar energy ends up traveling through the atmosphere, in that particular situation, you will observe that the atmospheric gases, dust particles, other influences, they end up diminishing the amount of energy which is received. So that is why there is a significant variation. So always you will find that in the lower latitudes, where the solar energy is still and the solar rays are slightly vertical, the amount of insolation received is much higher. Whereas when you talk about the higher latitudes, observe the higher latitudes, the solar energy and the solar rays, they cover a lot of distance within the atmosphere itself. So they get diminished. Hence, lower latitudes will receive greater amount of insolation, higher insolation. This is one of the factors due to which in the lower latitudes you will always observe a slightly higher temperature as compared to the regions of higher latitude. So here the lower latitudes you have a higher insolation, higher latitudes lower level of solar insolation. Okay. Then you have other factor when we talk about the revolution of Earth. Now we know that the planet Earth moves around an elliptical orbit all around the Sun. Now elliptical orbit in itself means that all the places of the orbit, they are not equidistant from the Sun. So in that elliptical orbit, there will come a position when the planet is closest to the Sun. That is what is referred to as the condition of perihelion, which is observed around 4th of Jan, when the Earth is closest to the Sun. At that point of time, the distance is around 147 million kilometers between the Earth and the Sun. Whereas, you will also have a condition after 6 months when the Earth is farthest away from the Sun. That is in the month of July. That is the condition of aphelion. Now, at this point of time, you will observe that the distance is 152 million kilometers. This is 4th of July. Right. So that is how you have a varying distance between the Earth and the Sun. Now this will influence the amount of insolation received by these places during different times. Now you have to understand that it does not necessarily mean that because we are farthest away from the Sun in the month of July, so we should experience cold temperature. This will not have much of a variation in temperature. Why? Because that variation in distance that we are talking about from 147 to 152 million kilometer, that variation in distance is around 5 million kilometers in outer space. That is vacuum. So the energy doesn't get dissipated. So in these conditions, it is the tilt of Earth on its axis, northern hemisphere being tilted towards the Sun or away from the Sun. These become the deciding factors in terms of what the temperature is going to be. So that is why it does not have much of an impact on temperature, but nonetheless, the amount of insolation varies. In the month of July, overall, average insolation is lesser. Insolation is lesser. However, there is not much of a variation in temperature because of the tilt of the planet on its axis, and also that lesser insolation or a higher insolation that ends up getting compensated by the greater exposure of solar rays through a larger part of the day, the wind factor, the pressure systems, all of them, they counteract the factor of temperature. Then you have another factor, that is the configuration of the land or the directionality of a land. So basically, here it is very simple that when we talk about, let's suppose, the planet Earth, let's suppose. Now here, if you consider in northern hemisphere, if let's suppose you consider this, and if you consider in the northern hemisphere a landform like this. Now this landform will have a northern slope, it will also have a southern slope. Now here, if you consider this to be the sun, the solar rays will be falling upon this. Now if you apply your logic that out of the northern face and the southern face of the mountain, which will receive more amount of solar energy? Always the southern face, isn't it? Because the northern face appears to be in a direction or in a configuration which is not facing the sunlight. Similarly, when we talk about the southern hemisphere, let's suppose we talk about the southern hemisphere. Here you consider a mountain. Mountain will have, let's suppose, a northern face, a southern face. So in the southern hemisphere here, you will experience that the northern face of the mountain receives greater amount of solar insolation. So the directionality of the land, what is the direction in which the sun and the land, they are counteracting with each other, that influences the amount of insolation as well. Now when we talk about the movement of the sun, the apparent position of the sun, that changes from one season to another or 1 month to another. Now here let's suppose if we consider the first image. Here you have the position of the sun depicted during the time of the June solstice, position of the sun during the time of equinox, and then the position of the sun during the time of the December solstice. Now let's suppose in this particular case, if you have a mountain here, like the Himalayas. Himalayas are beyond the Tropic of Cancer. Now this will also have a northern face, this will also have a southern face. Always, regardless of whatever is the position of the sun, the southern face will end up receiving more direct rays as compared to the northern face. In fact, this is the reason why the southern face of the Himalayas, they experience a much more habitable condition. And so is the case with the alpine mountains also. In the case of Alps also, you will observe that it is always the southern face of the Alps which have a more moderate temperature range where it becomes much more habitable. Then the last factor which ends up influencing solar insolation is the factor of altitude, that is height. Now when you consider different areas, let's suppose you consider an area at a sea level and you consider a mountain top. Now if solar rays are falling on both these regions, you will observe that the solar rays, they have to encounter much lesser number of particles as they reach the mountain top. Right? Whereas solar rays, they have to encounter much greater number of particles as they reach the base here, the sea level. This is the reason why you will observe that with increasing altitude, the insolation always tends to increase. Does not mean that the temperature increases, mind you. Just the amount of solar energy increases as you move higher up in altitude, right? So solar insolation is comparatively higher as one moves with altitude. But then why does the temperature not rise up? We have studied that higher up in the mountains, the temperature is lower. We know also that when you climb up in the mountains, it gets colder. If the mountain top receives more amount of insolation, why is it colder? Because even though it receives greater amount of solar insolation, the air above this is very rarefied, very less density of particles in this region. So automatically, immediately almost, all of that energy is lost. The heat is not trapped. Remember, we had discussed the concept of lapse rate in our previous video, where we talked about the density of air being one of the determining factors in terms of how the temperature ends up behaving. So here also, you will observe that as one of the deciding factors. So that is where you will observe that closer to the ground, more atmospheric particles come in the path of the solar rays, they diminish them. And these particles, they also trap the heat. And hence, despite higher solar insolation in the mountain tops, the temperature is always comparatively lower. Okay? So this is the factor of solar insolation. Now, what do we know and what do we talk about when we hear the term heat budget? Budget is a term that you would otherwise hear when you have the reference of, let's suppose, finances, isn't it? That is where you would have heard the term budget. The expenditure and the revenue, a kind of a perfect balance between them. Now here, when we talk about heat budget of Earth, it is basically a balance. Balance between what? Balance between the heat received by the sun, shortwave solar radiation, and heat lost by Earth through terrestrial radiation. Okay. So that balance which is achieved, whereby we have an account of what is the total amount of heat received by the surface and how much heat is lost by the surface. That is the concept of heat budget. And please understand, there has to be a balance. Otherwise, let's suppose the heat received is much high and the planet is unable to lose that heat. Over a period of time, the temperature of the planet Earth would have continued to rise up. It would have become very, very hot and unlivable. On the other hand, let's suppose the amount of heat received is slightly less, the amount of heat lost is much more. That means every day you would have a deficit of heat, means colder conditions. The planet would have become very cold to live in. So that is why heat lost and the heat received, they have to be almost balanced. Now here, we talk about global warming, we talk about climate change. The reason why we talk about the aspect of climate change or rising temperature is because of the disbalance or the imbalance created in that heat budget. You see, nowadays what is happening is that the planet is receiving the same amount of heat from the solar radiation. But then, due to the presence of carbon dioxide and some other different types of gases like water vapor, methane, etc., the greenhouse gases, that heat is not effectively being lost by the Earth's surface. That heat is being retained by the atmosphere. And hence, as that heat is being retained and accumulated day after day, you experience a substantial rise in temperature. So that is basically the concept associated with heat budget. Now here, what do you need to understand for your exam perspective? You need to keep one thing in mind, and that thing is that what are the various classifications of heat received by the Earth's surface and the classifications of heat lost by the Earth's surface. Is it in balance or not? That's it. So first of all, let us take a look at this. What kind of questions can be asked from here so that you are prepared for this? The questions in the prelims can be that in the heat received by the sun, where is it that the majority of the heat is consumed? Or where is it that the majority of heat is being lost? So that kind of classification you need to understand. Okay, so let us take a look at the heat received and the heat lost as well. And let us see if it finds a balance or not. Now, starting with the incoming solar radiation. If let's suppose you consider the incoming solar radiation to be 100 units. Mind you, we have to consider, or we here are considering the heat budget of the surface, not the atmosphere. There is a separate heat budget for the atmosphere also, but that is required for the optional level. Here, the heat budget for the surface. So if 100 units are being received, you will observe that almost 27 units are reflected by the clouds in the outer space itself. Right, because the cloud cover is white on top, so they reflect 27 units. Then 6 units of that heat is scattered from the space itself, never reaches the Earth's surface. 2 units are lost after being reflected from the Earth. So this is directly lost. Then 14 units are absorbed by the atmosphere. That particles, they end up retaining and absorbing that heat. Then what is the amount of heat that the planet receives? 34% or 34 units by direct absorption, and slow and steady absorption by the scattered heat from the atmosphere. So overall, the heat received out of the 100 units, the heat received by the surface is how much? It is basically how much? 34 plus 17, and that comes out to be 51 units. Now, in order to ensure that the planet doesn't get extraordinarily heated up, we need to understand that the planet must lose 51 units of heat as well. Does the planet manage to do so? Yes. How? So, that is something which happens in the form of long wave terrestrial radiation. The long wave terrestrial radiation. Here, observe this. Now, due to direct terrestrial radiation, the planet's surface loses 23 units directly by terrestrial radiation. So, by the terrestrial radiation, 23 units are lost. Right? Then, convection, that is heating, and thereby leading to the convection current in the atmosphere. So, the planet surface, when it gets heated up, it will heat the air also, and the air will tend to rise up and will heat the surrounding vicinities. So, that is also a methodology of losing of heat. So, here you will have another 9 units which are lost in that way. And then you have 19 units which are lost from the Earth's surface, including the water bodies, land areas, etc., where the heat is lost by the process of evaporation and eventual condensation. Evaporation, after all, also means what? Loss of heat. Any area where evaporation is happening, that area becomes cooler as compared to earlier, which means what? That heat has been lost. So, evaporation and condensation across the planet on a daily basis, if you consider the long-term average, there also you lose around 19 units. So, overall, how much does it come out to be? It comes out, if you add this loss, it comes out to be roughly around 51 units. So, by various mechanisms, the planet's surface manages to lose 51 units of heat, and it had also gained 51 units of heat previously. So, that is the concept of heat budget, where the planet is able to maintain and find a balance in terms of heat received and heat which is lost. So, this is what is required for the examination. So, in this video, what is it that we have studied? What is solar insolation? What are the factors which influence solar insolation? And then, is it the case that solar insolation will always influence the temperature? The answer is no. So, if solar insolation does not always influence the temperature, then what happens? There are other factors like wind movements, cloud formation, convection, etc., which will influence the temperature, ocean currents, etc. Now, the various factors: angle of inclination of planet Earth, then the revolution of Earth in an elliptical orbit, conditions of aphelion and perihelion, the directionality or the configuration of the land. If the land is facing the sun, more heat or more insolation will be received. If the land is not facing the sun directly, like the northern face of Alps or Himalayas, lesser insolation will be received. And then eventually we looked into the factor of altitude. Also, why with change in altitude, while the insolation tends to increase, but the same does not happen with temperature. Okay, so these are the factors that we have basically looked at and then taken a look at the concept of heat budget as well. I hope that this has added some amount of basic concepts to you, and then please follow it up with the already uploaded video for the portion of lapse rate and the temperature inversion. That will give you an overall comprehensive idea and analysis of the entire chapter, more than sufficient to tackle prelims as well as the mains type of questions. If you have liked the content, please put that in the comment section and don't forget to click on the like, share and the subscribe button. So till we meet again, do take care of yourself and thank you.
NCERT books are unavoidable to crack the IAS exam. Not only is the content of these books authentic, but these books also help a civil services aspirant to build conceptual clarity. And most importantly, lots of questions in the civil services examination are directly asked from NCERT books. But the aspirants often find it difficult to cover these books, or worse, they even end up ignoring these books. We at Unacademy IAS English are going to make the reading and understanding of the NCERT books easier. We present NCERT Fundamentals course, a free initiative of Unacademy IAS English. What are the highlights of this program? Comprehensive coverage of the most relevant NCERT books for the civil services exam. Prelims and mains practice questions in each session to test your understanding of the fundamental concepts. This course begins from 12th of July every day at 6 p.m. right here on our YouTube channel. Subscribe to the channel now.